All right, welcome everyone. So in this video, we are going to define what we mean by a system of linear equations. And so before we talk about a collection of linear equations, let's first be sure that we are clear and define what we mean by one single linear equation. So a linear equation in variables x1, x2, all the way up to xn is an equation that can be written in the following form down here. So each term in this equation has a different variable x1, x2, up to xn in it, and that variable occurs to the first power, so the only thing that we can multiply each of these terms by would be some constant a1, a2, an. So we call the collection of all of these constants the coefficients of the equation, and on the right side we have this constant b, so this is also a constant. And so our variables in the equation we're denoting with x1, x2, all the way up to xn. And so let's consider the following example down below. So here are three different equations given in A, B, and C. And so for each of these equations, we want to determine whether it is linear in the variables x1, x2, and x3. So you may want to just pause this video just to make sure you check your own understanding, but I'll go through and discuss each of these right now. Okay, so in part A, we've got the following equation. Cosine of pi over 3 x1 plus e to the fourth times x2 minus x3 over pi is equal to minus 5. So this is definitely a linear equation. Here are our variables, x1, x2, and x3. And here are our coefficients. So in this case, a1 would be the cosine of pi over 3. It is maybe not the nicest looking number, but it is a constant number. Over here, in the second term, our constant would be e to the fourth, so that would be our a2. And for the third term over here, we have a constant coefficient of minus 1 over pi. And we have our constant on the right side. So this is a linear equation in x1, x2, and x3. In B, here we have a second term which has an x1 and an x2 in it. So if we have a linear equation, the only thing that can be multiplying, say, the second term would be a constant number. And so here we're multiplying x2 by another variable x1. So though the numbers are nicer in this equation, that is not a linear equation because we have x1 being multiplied by x2. And in part C, this is not a linear equation, and that is because of this term right here. Each of the variables, x1 up to xn, they should only appear to the power of 1. And so in this case, the square root of x2, that is not linear in x2. So a system of linear equations would now be a collection of one or more linear equations that involve the same variables. So for example, here is a system of two linear equations with two unknown variables, x1 and x2. So here's the top equation, that is linear. Here's equation number 2, that is linear, and these are linear in the same set of variables. And now on the right, we have a system now of three different linear equations that are in terms of these four variables, x1, x2, x3, and x4. And we've got 1, 2, 3 different equations. And again, these are all involving the same variables. Notice that this second equation is missing x3, but we can still consider it linear in x1, x2, x3, and x4, just the coefficient in front of x3 is 0. So here are two systems, and for the most part this semester, when we're doing things by hand, we'll be working with systems of, say, 2 or 3 equations in 2 or 3 unknowns. Our strategies are going to scale up very nicely to systems of 1,000 equations with 1,000 unknowns, which actually occur when you're working with large data sets. Just we'll be using technology at times when the systems are really large.